Today we are going to discuss fuel and its combustion. The general term is burn, but the scientific term is actually combustion. Combustion is a scientific term for burning. So what is the combustion? It's a chemical reaction between the substance and oxygen present in the atmosphere. So this is basically a chemical reaction. So fuel is a source of heat energy, chemical energy in the form of a fuel. Now if we burn this, that means if we facilitate some chemical reaction with oxygen, that is the combustion. So fuel is compound of carbon and hydrogen. The compound is basic component of a fuel is carbon and hydrogen. Say this is one compound of hydrogen and carbon. Say this is another compound of carbon and hydrogen. So these compounds are fuel. If burnt with oxygen, that means if we facilitate the chemical reaction with the oxygen, then what is generated? We get heat, also we get some light, and that is the final product of combustion. Burning of fuel with oxygen produce heat. So this heat is very much essential for in engineering, in thermodynamics, in thermal engineering, because we already discussed a basic thing about heat engine. A heat engine convert heat energy into mechanical energy. So that is why this heat, which is in the form of chemical energy with the fuel, is very essential. Okay. Now come to the heat generated due to the combustion or burning. The heat generated we use for what are the purposes? In domestic usage we always use fire. That means we always use the heat produced by the combustion or by burning of the fuel. And in industrial application, in engineering application, these are the heat used in heat engine. Okay. So what is a heat engine? In second law of thermodynamics we got heat engine is a device which convert heat energy into mechanical energy, and part of the heat energy is rejected to the environment. That is the basic principle or definition of a heat engine. So what is this? Use convert heat energy into mechanical work. Okay. That is why we have petrol engine, diesel engine, 2-stroke, 4-stroke, whatever be the engine. These are all example of heat engines. They converts the heat energy to mechanical energy. And where from the heat energy is derived? By burning or by combustion of fuel. That is about fuel and combustion and use of heat. Now comes the question, what are the types of fuel? You all know there are basically three types of fuels: solid fuel, liquid fuels and gaseous fuels. So solid fuel you can give many examples, say wood, coal, like this. Liquid fuel you know, petrol, kerosene, diesel, any other aviation fuel and so on. These are some liquid fuels, and also the gaseous fuels. And these are used in the heat engine. This heat engine may be of external combustion engine and also in internal combustion engine. Okay. Now if we talk about what is external combustion engine, these are the engine in where the fuel is burned outside the cylinder or chamber. So there will be one chamber to burn the fuel, and this chamber is external to the system in external combustion engine, and this is internal to the system. That means the fuel is burned inside the cylinder and piston arrangement, and that is why it is called internal combustion engine. That is the part of the system. But this is outside. That means that we can say the combustion in external combustion takes place outside the system. So internal combustion engine, you know, all that petrol engine, diesel engine, these are there are many other engines. These are some examples of internal combustion engine. But if we talk about solid fuels, it seems that this is not very much suitable for internal combustion engine because this is burned inside a chamber. And if we burn, the first thing is the distribution of the fuel is very difficult because it is a solid. Okay, and if we manage the distribution problem or issue, but there is another problem that when we burn solid fuel, it produces some ash, residue. Okay, that residue has to be removed from time to time. In case every time the residue has to be removed from the chamber, internal combustion engine. So that is another difficulty using solid fuels. And that is why in all internal combustion engines, what are the types of fuel used? It is either liquid or gaseous fuels in internal combustion engines. Okay. So solid fuels, there are some advantages and disadvantages that we will discuss a little bit. Also for liquid as well as gaseous fuels. So what are the classification? That is the fuels in solid form is called solid fuels. Fuels in liquid form, it is liquid fuel. And so as in gaseous form, it is called gaseous fuels. So we can discuss something about solid fuels. What are the examples? For example, wood is an example of solid fuels. Okay. Now if we process this wood, so these fuels means these are some basically compounds of carbon and hydrogen. If we process this wood, we can make it coke. Okay, what is a coke? Basically, if we burn coke in absence of air, not 100% absence, we in limited supply of air or oxygen, then it will become coke. That means the carbon and hydrogen component will remain there, but the moisture and some other parts will remove, and that is basically the wood. Now there is another example of solid fuel that is called the peat. What is a peat? It's a soft, dark brown coal. It is also coal, and this is the first step in the formation of the coal. Coal is first formed. We all know coal, for formation of the coal, it takes millions of years. So that means at the first stage, what is the origin of a coal? It is the organic matter, something living things. Once it was living things, it may be plants, animals also. So these things are converted into coal. That means if it is in the solid form. So during this formation of the coal from the organic origin, the first step, it is called a peat. So if we give more times, but more times means millions of years, some million of years, then this peat will become lignite. So peat is not very good fuel. So this is called charcoal. No? Charcoal is a carbon residue. Actually, what is this? This is the residue. This is soft and dark. So we need, if it is hard, then it is good. If it is soft, then it is difficult to handle, and it will produce so many smoke while we burn. Okay? So if we give more time, this peat will become lignite. So color will slightly change. That is why it is called brown coal also. This is brown in color, and this is, actually we can say this is coal. The previous state, peat is not considered as coal also. But since it is in the formation of the coal during the process, we can say peat as considered as a coal. So the lowest quality coal is the brown coal or lignite, which is the second stage after peat. And what is this briquette coal? So it comes from the term brick, no? Like brick. If it becomes solid, it becomes something like, it has some strength, it becomes brick-like structure. So that is why it is called, process is called briquette. So if we compress peat, then also it will become brown coal. But this compression should be at high pressure and high temperature also. So this way we get brown coal, and brown coal has low carbon content. Okay, carbon content of this coal is less. So definitely if we burn this lignite or brown coal, then it will produce less heat, because what is the heat? A chemical reaction with the hydrocarbon, carbon and hydrogen and the oxygen. So it will form carbon dioxide and some water vapor, and also it will produce some heat as well as light. So this heat energy depends on this content of the carbon, how much carbon is there, that will accordingly it will produce heat. So carbon content is less, this is a low grade coal, this quality is not good. Next come to bituminous coal. This is also called bituminous simply or bituminous coal. And bituminous coal are black. This is also called black lignite. The previous was brown coal and it was called lignite. But after lignite, if it get more time, then it will become bituminous. That means the quality of the coal will increase. And this is black in color. That is why it is also called black lignite. Okay. And this is the highest quality of coal because it get more time to form this bituminous, then this is good quality coal. And generally bituminous coals are used in steel industries and in power plant. Now what electricity we get from the thermal power plant. So in the thermal power plant, coal is burned to produce heat, and that coal is generally bituminous coal. Okay, that is, if we process this bituminous coal, then we call it pulverized coal. What is pulverized? Basically, if we powder the coal, crush the coal, and it will become dust type coal, or we can say powdered coal. Fine particles will be formed, and that is called pulverized coal. And in actual practice, in thermal power plant, this pulverized form of coal is used. But originally the coal is bituminous coal. If we powdered it, then it we will call pulverized coal. Then next come the anthracite. Okay, anthracite is another coal. In some sense, this is very highest quality of coal. Okay, and it produces very less amount of smoke. So that is a very good for use at home. Inside the room also we can burn anthracite coal because it produces very less quantity of smoke. Okay, room heating by using a stove we can use anthracite coal. So in Assam, that not very good for industrial point of view because Assam coal has high content of sulfur. Whatever coal is available in Assam, those has some high content of sulfur. So if we burn that coal, it will produce sulfur dioxide and that will go to the environment. And sulfur dioxide is a pollutant. But so if we burn that type of coal having more content of sulfur in the industries, it will produce many sulfur dioxide and it will be released to the atmosphere. So that has some environmental compliances. How much amount of anthracite, not anthracite, sulfur content coal can be used. Okay, these are some examples of solid fuels. There are another examples, that is dung. Cow dung or animal dung we can use as a solid fuel. Then come to liquid fuels. The original thing is, it is a petroleum product we can say. The same origin is biological origin. Under different condition, it produces another product that we call the crude oil. So crude oil we have to refine, that is done in a refinery. From refinery, we get many products and byproducts upon refining the crude oil. And those kerosene is a liquid fuel, diesel is a liquid fuel, petrol, aviation fuel used in the aircraft, LPG, this is a gaseous form, LPG, liquid petroleum gas. Why I write LPG? Because it is in liquefied. Actually it is gas, but it is kept in the liquid form under high pressure. That is why we can consider it as a liquid fuel. Then naphtha. Okay, naphtha is another very volatile. If it comes in the atmosphere, it will immediately vaporize. So ethanol is another liquid form of. Now come to the gaseous fuels, which are basically the natural gases. Say biogas is a gaseous fuel. CNG, compressed natural gas. There is one called water gas. Water gas you studied in the chemistry. That is basically a mixture of carbon monoxide and hydrogen. That is water gas. We will not go to the details of the water gas, how it is. Another is blast furnace gas. So you have studied blast furnace also in chemistry, and a blast furnace byproduct is a gas, and that gas has some carbon content. So that can be used as a fuel, but that is not very good quality of fuel. But definitely blast furnace gas is a fuel, gaseous fuel. Then there is coal gas. It's a mixture of hydrogen, methane and carbon monoxide. Similarly, there is coke oven gas. This is also a mixture of hydrogen, methane, ethane, and also it may contain benzene, ammonia and sulfur, hydrogen sulfide. These are coke oven gases. So from our thermal engineering point of view, the most important thing is liquid and gaseous. Out of that, this diesel and petrol and also the aviation fuel, these are extensively used in industrial application or in vehicles also. Okay, these are some classification of fuels and its use and processed form. After processing, sometimes we give different names. For example, crude oil is the most raw form of oil, but if we process it, refine it, we get different types of fuel with different properties. Accordingly, we name these fuels like petrol, diesel, kerosene, aviation fuel, like this. Now, if we come to coal again, what are the uses of coal? It has two major uses. One is domestic, at home. In some places, coal is extensively used for domestic purpose, for cooking also, and for many other purpose, this coal is used. And also for commercial uses. That is very important from our subject point of view. There commercially we use coal in thermal power plants. So what should be the properties of a coal that is required to be used in commercial sector particularly, also in domestic sectors? So if we burn coal, it should have low ash content. After burning, generally all solid fuel produce some ash. And if the amount of ash produced is very much, then it is not considered as good quality solid fuel or good quality coal. So ash content should be less. And high calorific value, this we will discuss in details maybe in the next class. Calorie is the unit of heat. So high calorific value means what? If we burn coal, it should produce more heat, and that we call calorific value. Then low sulfur content. If sulfur is present in the coal, then if we burn coal, it will produce what? Oxygen, or if it combines with oxygen, it will produce carbon dioxide. Also, the amount of oxygen is less, it may also produce carbon monoxide. Then, if the same coal contains some sulfur, then the sulfur will also be oxidized and it will form sulfur dioxide. It will also form sulfur trioxide, like this. This we discussed in the environmental education, that we call the SOx, oxides of sulfur. So the coal should contain less sulfur. That I gave the example in Assam coal has high sulfur content. Okay. So if the sulfur is more, then it will cause more environmental pollution. And there is some restriction how much sulfur should present in the coal used in the industries, in thermal power plant and so on. And another required quality or property of coal is that it should burn freely without agitation. Okay, it should not cause any agitation. Then ease of pulverizing. So pulverizing, I described, it is the process of powdering the thing. So if we easily can crush the coal, solid fuel, and make it in a powder form, fine particles, then what we can do, we can spray the coal. We can also spray it. So if we can spray the coal, that means pulverized coal, powder of the coal, then it will burn very freely, easily and instantly in industrial situation, in thermal power plant. So if we can easily pulverize powdered of coal, then that is considered as good quality or good property of a coal. Okay? Fine. So come to the liquid fuels and its advantages. It takes less space of storage. So whenever we talk about fuels, we have to store it because we need, in the industries, we need huge quantity of fuels. So for that we have to store it in some place, and from that we will keep on using the fuels. So if we talk about liquid fuels, it takes less space for storage compared to gaseous fuels. Okay. Then another advantage is better calorific value. If we burn liquid fuels, it will produce more heat than solid fuels. Then handling and transportation is easy. If we have the fuel in the liquid form, we can take it in a tanker or so and transport it to any other place safely. Okay, handling is easy. Then it is a clean fuel compared to the coal, and it produces no dust, but it will produce some smoke. Very fine particles it will produce, but compared to the coal, the dust content, smoke content is very less in liquid fuel. Okay. Then ash handling. No ash is produced. So whatever little amount of ash is produced, it can be handled. In fact, it never produce any ash, but it produce some smoke which settle down in different places. So there is no question of ash handling. Higher combustion efficiency. That means, there are some disadvantages of liquid fuels. Liquid fuels are costlier than solid fuels. There are some fire hazard. Although transportation and handling is easier, but it can catch fire very easily. And the cost of storage containers and transportation containers are more. That means we have to transport the liquid fuel in a tanker. So the construction of that container tanker is more. Otherwise, transportation is good, but the transportation equipment like containers, those are more costly. Gaseous fuel advantages. Control of combustion is easier. How? If we stop the supply of gas, the combustion will stop. As you used in the LPG, so LPG is actually storage is in liquid form, but while we burn the LPG, then it is a gaseous form. So if we stop the supply, then the combustion quickly stops. But same thing you think of, you are burning some coal, then you cannot extinguish the fire instantly, because that means you cannot control the firing or combustion very easily. Complete combustion of fuel is good because first mixing with air. So you see, these are some gaseous fuels. Okay, they are dispersed, they are distributed. So the air can enter into this fuel easily. So that means completely it will be combusted instantly. But just think of a solid fuel. This is a solid fuel. This whole mass of solid is a fuel. Then this part will be combusted easily because this is in contact with the air or oxygen. But the inner part will not get the oxygen required for the combustion. So it will take some time to complete the combustion of the solid fuel. And that is why we do pulverization. What is pulverization? Powdering of the solid fuel. So if we powder it, then this oxygen can reach into the each and every particles easily. That means complete combustion is possible. Another advantage is gaseous fuel can be directly used in the IC engine. Okay, gaseous fuel can be used in the IC engine also, it can be used. In fact, in maximum cases, liquid fuels are used, but gaseous fuel are also very suitable and higher combustion efficiency. Definitely, it will give more efficiency. No ash and smoke. In solid fuel, there are ash as well as smoke. In liquid fuel, there is no ash, but there is some smoke. But in gaseous fuels, there is no ash, no smoke. You have the example, experience at home. An LPG, if you burn it, will not produce any smoke or ash. Pipeline supplies avoid storage and transportation. So if we have a pipeline for transportation, so physical transportation through a vehicle is not required. So if we connect the gas connection to different places where it is supplied, then we need not carry the gas in a tanker or so. So you need not transportation with a vehicle or transport arrangement. What are those? Highly inflammable. It is very good fuel, but it is very highly inflammable and it can cause many hazard and loss if it gets fire because of the any accident or so. Huge storage space is required if public supply line is not available. But you just think of this LPG distribution system in whole country. There are so many establishments, gas agency, gas bottling plant, transportation, everything is involved with this supply of gas. But if we have a pipeline supply system, then it becomes very easier. You need not go to the gas agency, book the gas cylinder, take the gas cylinder, carry it at home, connect it and then use it. But if there is pipeline and there will be one meter only, may say like our electricity meter, then whatever we use, that will be recorded in the meter maybe. Actually, the disadvantage is what? If pipeline is not there, then it is very disadvantage because gas takes more volume.